All right, number 10. We have Ryan, who wants to build a ferret cage with a rectangular base. The perimeter of the rectangle can be no greater than 20 feet. We know the length is at least 6 feet. And the problem defines our variables for us. So x is length, y is width. All right, and this problem asks us to write a system of inequalities and then graph the system of inequalities. So we have one situation, one sentence that says that the perimeter of a rectangle, or of this ferret cage, is no greater than 20 feet. And then we have another criteria, another condition that says the length is at least 6 feet. So let's use these two sentences to form our inequalities. Recall that the perimeter of a rectangle is twice the length plus twice the width, and this can be no greater than 20 feet. In other words, 20 feet is the maximum or the most it can be. So this number here, whatever this number is, has to be less than or equal to 20. And then we also know our length, which is x, is at least 6 feet. So at least meaning it can be more than that. Okay, so it could start at 6 or it can be more than that. So at least, greater than or equal to 6 feet. Okay, so let's see what this looks like on a graph. It's my hope that you would use graph paper doing this. 2x plus 2y is less than or equal to 20. We would use intercepts to graph that. The x and y intercepts are both 10. Okay, we have a solid line. Should have used red, sorry. We have a solid line because it's less than or equal to, and our shading is going to go below the line. Now notice I'm staying in the first quadrant here because both length and width have to be positive. So that actually gives us another condition here that we didn't consider before. But the width has to actually be greater than or equal to 0. So even though that condition is not stated, it is important to state it ourselves, that the width must be greater than or equal to 0. So we've graphed one inequality, and kind of by default we graphed the y is greater than or equal to 0 because we're staying in the first quadrant. We also need to graph the x is greater than or equal to 6. So recall that that's a vertical line, 1, 2, 3, 4, 5, 6. A vertical line at x equals 6, and the greater than or equal to means we're going to shade to the right, and again we're staying above 0. So we're really looking at this region in here, this triangular region, as our solution region. And the last part of this problem asks for one possible dimension for the cage. Now remember, the solution to a system of inequalities is anything that lies in the shaded region, the shaded portion of the graph. So the easiest thing to do would be to just simply choose a point that's in this shaded region as a possible dimension for the graph. So for example, we could choose the point 7, 1. So we could have a length of 7 feet and a width of 1 foot. Now that's a pretty narrow cage. I don't know if that's practical, but we could do 7. by 2 feet as well. But really anything, we could do 8 by 1, you know, or even 8 by 2, I think, is in this region as well. Okay, so any number that's in this region is acceptable. Even fractions would be okay. So dimensions like, you know, 7.5 feet by 1.25 feet would be fine as well. So again, anything in this shaded region is an acceptable answer. There's not only one right answer.